Find the area of the triangle whose vertices or corners are A 3, 6, B 7, 2 and C 4, 1. So if we have a closer look at our graph, you can see that the point A 3, 6 is here. We go across to 3 on the x-axis and up to 6 on the y-axis. So 3 on the x-axis, 6 on the y-axis. So that's that point there. B is 7, 2, so we go to 7 on the x-axis and 2 on the y-axis. So 7 on the x-axis, 2 on the y-axis. That gives us this point here. And then C is the point 4, 1, so we go to 4 on the x-axis and 1 on the y-axis. So 4 on the x-axis, 1 on the y-axis, and it gives us that point here. So A, B, C is our triangle. So solution method 1. Step 1, construct a rectangle around the triangle ABC. So let's have a look at our triangle. So we're going to draw a rectangle, and we must make sure that we touch off each corner of our triangle. So we're going to draw a line straight down, a line across, a line up, and a line back across again, making sure that each point of our triangle touches off the edge of the rectangle. And what we've actually drawn is 4 triangles. So we have 1, 2, 3, 4 triangles inside of this rectangle. So we start by getting the area of the rectangle. So the rectangle is 1, 2, 3, 4 units across, and 1, 2, 3, 4, 5 units down. So 4 multiplied by 5 gives us 20 units squared. So the area of the rectangle is 20 units squared. Step 2, we're going to get the area of triangle P. So I'm going to call this orange one here triangle P. And we're going to add that to the area of triangle Q. So we're going to call this blue one triangle Q. And we're going to add that to the area of triangle R. So we're going to call this yellow one triangle R. So the formula for the area of rectangle is half times base times height. So for the area of triangle P, which is this orange one, it's going to be a half multiplied by the base, which is 1, multiplied by the height, which is 5. So a half times 1 times 5. The area of triangle Q is going to be half times base times height again. So half times the base, which is 4, times the height, which is 4. So half times 4 times 4. And the area of a triangle R is going to be this yellow one here. And it's going to be half times the base times the height. So half times 3 times 1. So half times 3 times 1. So half times 1 times 5 plus half times 4 times 4 plus half times 3 times 1 is 12 units squared. Because half times 1 times 5 is going to be half of 5, which is 2.5. And half times 4 times 4 is going to be half of 16, which is going to be 8. And half of 3 times 1 is going to be half of 3, which is 1.5. Add those together to get 12 units squared. Step 3, the area of ABC, which is the triangle in the middle that we're trying to find the area of, is going to be the area of the rectangle, which is 20 units squared, minus the area of the 3 triangles added together, which is 12 units squared. So 20 minus 12 is 8 units squared. So the area of the triangle that we're looking for is 8 units squared. Method 2. We can also use the formula to find the area of the triangle. We need to move, which means translate, the triangle until one of the vertices or corner is 0, 0. So I'm going to choose the bottom left corner, which is 4, 1. and I'm going to move it down here so it's at 0, 0. So, how did I get from 4, 1 to 0, 0? Well, for my x value of 4, to move to my x value of 0, I had to minus 4. So we take 4 away from each of the x values of the other points on our triangle. And to get from a y value of 1 to a y value of 0, I had to minus 1. So I'm going to take 1 away from each of the y value of the 3 points. So these are my 3 points, or my 3 coordinates of the vertices of my triangle. So I'm going to take 4 away from each for x value. So I have an x value of 3, and 3 minus 4 is minus 1. And I have an x value of 7, and 7 minus 4 is 3. So there are my 2 new x values. Now I'm going to take 1 away from each y value. 6 minus 1 is 5, and 2 minus 1 is 1. So these are now the coordinates of my new triangle. So I have 0, 0, minus 1, 5, and 3, 1. So I'm going to use this formula, which is the area of the triangle formula from my formula book. A half times the modulus, these lines mean modulus, of x1 multiplied by y2 minus x2 multiplied by y1. So when we see these lines, they represent distance. They also represent modulus, which means we're going to have a positive answer, because you couldn't have a negative distance, it wouldn't make sense. So although we're talking about area, those lines are usually used for distance, but in this case they're going to be used to make our answer positive. So I'm going to swap x1 for minus 1 with brackets around it, and y2 for 1 with brackets around it. Bring down the minus. I'm going to swap x2 for 3 with brackets around it, and y1 for 5 with brackets around it. We do not use the coordinate 0, 0. We only ever use the other 2 coordinates. Minus 1 by 1 is minus 1. 3 by 5 is 15. Bring down the minus. Minus 1 minus 15 is minus 16. Half of minus 16 is minus 8. But we're really getting half of positive 16, because these lines tell us that we need to keep the number inside here positive, and half of 16 is 8 units squared. So the area of this triangle is 8 units squared, and since this triangle is the same size with the same side lengths and the same angles, this triangle is also 8 units squared. So these 2 triangles are congruent, which means that they have the same sides and the same angles.